Hi, this is Mrs. Myers, and we are going to start talking about transformations. There are three transformations in today's lesson, translations, reflections, and rotations. A transformation is just a change in a figure. Um, it's a function or mapping meaning from one polygon or figure, it maps to a new polygon or figure. And it changes in either size or position. It's not going to actually change the shape. It's still going to be the same shape. When we do this kind of transformation, and you can think of like a transformer, remember those toys? Transformers that change from one thing to another. The pre-image is the original figure, and the image is the resulting figure, the one you end up with after the transformation. Rigid motion is, okay, sorry, we got interrupted there, but rigid motion is a transformation that does not change the size or the shape of the pre-image. So in other words, the pre-image is congruent to the image. It's called an isometry. In other words, it changes in position, but it doesn't change in size or shape. Okay? So a transformation maps every point of a figure onto its new image, right? So there's going to be corresponding parts, just like when we talked about congruent triangles or congruent polygons. Every point on the pre-image has a corresponding point on the image that we say it maps to that image, that new point. So if you see here, the rigid motion preserves the distance and the angle measures. In other words, the lengths of the sides and the size of the angles are going to be the same. Okay, so there's a little notation here that you need to know. This one says triangle JKQ, and then this arrow means maps to triangle J prime, K prime, Q prime. That prime notation is a signal to you that that's the new image. That's the new resulting image with the prime notation. If there's no primes, that's what you know is the pre-image. Okay, so we start with triangle JKQ, and it maps to J prime, K prime, Q prime. So obviously J corresponds with J prime, etc. There's three types of isometries, three types of transformations that don't change the size, and they're called translations, which is like a slide, a rotation, which is like a turn, and a reflection, which is like a flip, like a mirror image. So translation is if you just slide an image over. You could go to the right, to the left, up, down, diagonally, whatever, but it doesn't change the position at all. It just changes the location. So a translation vector is just an arrow that shows you, okay, I'm moving this image and I'm just sliding it up and to the right here, and that becomes the new image. That's a translation, a slide. Rotation is if you actually rotate, obviously, and it's going to be like a turn. This is the center of rotation. It's what we call, it's kind of like, if you think of it as a wheel, that's like the middle, the axis of the wheel, and it's just rotating. So this is actually rotating this way. You can kind of think of it as the hands on a clock too, where that center is the middle of the clock where all the hands are held together, and then it just rotates. Okay. I'm just looking over here. The pre-image and its image are equidistant from the center of rotation. So this point here, let's call it A, when it becomes this point, A prime, it's still the same distance from the center of rotation. So it's never going to get any closer. I always think of like a watch, like a Mickey Mouse watch. Do you ever see those with the Mickey Mouse hands? Right? His hand, as it rotates around the clock, it doesn't get any closer to the center. It just keeps the same distance away. So that rotates around. Okay, a reflection is just goes over a line of reflection. It's like the mirror where the image gets reflected across. So this would be the pre-image, maybe A again, and this would be its image, A prime. If this was B, it would reflect over, and that would be B prime. Notice that these points are equidistant from the line of reflection. So if I measured from here to here, it would be the same as from here to here. Right? So the reflection doesn't get any closer to the mirror either. All right, sometimes we do a composition of transformations where there's more than one thing happening at once. So in this triangle ABC, and when I look at this diagram, I can tell which one is the original because there's no primes. A, B, C is the original. And the first thing it does is it rotates 90 degrees counterclockwise, and it becomes A prime, B prime, C prime. But then it translates 4 units down. This point A goes 1, 2, 3, 4 units down. Oh, sorry. It's actually not right because of the, oh boy. So it's actually not translating. This is actually a reflection because A reflects to A double prime. Sorry, A prime reflects to A double prime. B prime reflects to B double prime. And C prime reflects to C double prime. So it's actually reflecting over the x-axis. So we should change that. Reflects over x-axis onto A double prime, B double prime, C double prime. Okay, so this is just some practice with these new vocabulary words. Translation, you can slide this in any direction, maybe just move it over. Rotation, well, maybe pick a center of dilation, a center of rotation, and just rotate it. Reflection, maybe make a line of reflection and reflect this. Going to come out over here somewhere. Right? Rotation, this is going to rotate maybe like this. I didn't do that very well. Right? We want this to be the same distance away, so it's going to be more like that rotation. So you can practice those a little bit. These are some practice on just recognizing what type of rotation or reflection or translation we have here and what the correspondence is. So if this is triangle XYZ, it moves or maps to ABC by A. You could tell there's a line of reflection here, so this is just going to be reflection. And so the image of angle X, meaning XYZ, right? The image of X, meaning X is the pre-image. What's the image of X? That would be reflected down, and that would be angle A. Right? So that's what this practice is saying. I'm going to post these answers for you, but you can try practicing these different things, recognizing the rotation and the correspondence. I just wanted to show you one other thing. You're going to see practice like this in the packets that we do to practice. Okay, so you're going to see some practice like this, and it says you may use patty paper, which we have in school. It's really tracing paper. Sometimes it helps you to learn how to move these things. But really, this is all put on a grid. So when they tell you to translate A, B, C, D, E to A prime, B prime, etc., they give you this hint here. There's E prime. So all you have to do is find where the original E is and count. 1, 2, 3, 4, 5, 6, 7 to the right, and up 1. And that's E prime. Well, then you just repeat that same exact thing with all the points. So here's A. 1, 2, 3, 4, 5, 6, 7 to the right, up 1. That's going to be A prime. B is going to be 1, 2, 3, 4, 5, 6, 7 to the right, up 1. That's B prime. C, 1, 2, 3, 4, 5, 6, 7 to the right, up 1. That's C prime. And D, 1, 2, 3, 4, 5, 6, 7 to the right, up 1. That's D prime. So then just connect it, and you should have a figure, a resulting image that is congruent to your original. Notice this one goes to the left and up, and you just have to count it out to do it. I just wanted to show you that. Also, eventually then you're going to have some practice doing this on the coordinate plane where you're actually taking notice of the coordinates. So if you take point A, which is 1, 2, negative 3, 3 is its pre-image, and then when we move it 4 units to the right and 2 units down, well, it goes 1, 2, 3, 4, and then down 2. Well, we end up at the point 1, 1. And if you keep doing this, you're going to notice that there is a pattern here to what happens to x and y. It turns out that all you have to do, if it moves to the right or to the left, you add or subtract to the x coordinate. So this one ends up being x plus 4 because it moved to the right 4. And then it ends up being y. What do we do to the y to get from 3 to 1? It's just y minus 2 because that's down 2. And that's what we did. We moved to the right 4 and down 2, and that was an x plus 4 and a y minus 2. And you're going to see that, that pattern there. So when you're asked to do that down here, it just is saying take your original xy, add 5 to the x, add 3 to the y. So if we have this point h, here's our 0, 0, oops, 1, 2, 3, 4, 5, 6. This is negative 6, negative 1. If we're going to add 5 to it, negative 6 plus 5 is going to give us negative 1. And then the y is at negative 1. We want to add 3 to it. Negative 1 plus 3 is 2. So our h prime is going to be at negative 1 up to h prime. Okay? All right. Well, thank you, and we will continue this later.